if you want to work on your car and you need it held up in the air, traditionally you would use a hydraulic floor jack and jack stands. Now, another option available to us in the modern day is quick jacks. The way quick jacks work is that you have a sturdy frame in order to hold weight. Inside the frame is a hydraulic cylinder. The hydraulic cylinder has hydraulic pressure on one side in order to lift, and pneumatic pressure on the other to assist when lowering. Now, the hydraulic cylinder is attached to a power pack, which we're going to head over here and see. So the power pack is made up of an electrical motor, a manifold with some valving, and a small gear pump within the hydraulic reservoir. Quickly, before we're going to get to the math, we're going to raise the quick jacks with nothing on them to show you how you work. So that is how the quick jacks raise. Now we're going to get into how the force is split into vectors, as well as how much hydraulic pressure is needed in order to generate enough force to lift the vehicle off the ground. Before we do get in the math, we will need to get into what angles they are at, because that is very important for our math. Here is a closer shot of the components. All right, so now we have the quick jacks positioned and ready to lift my car. We're using wooden planks and rubber blocks as spacers, so that because my car is smaller and has high ground clearance, and so we need a little bit more height when working on my car. So using the protractor, we've determined that the angle is 10 degrees, which is going to be very important. Now, cutting to the car being lifted, it is on the safety stops, ready to be lowered. The angle when it is on the safety stops is 26 degrees. So now we're going to get into the math. All right, so here is our math. We're just going to quickly run through this because I've already done it for you, but we're just going to make this, a little more understandable. So first, we have the total weight of my car, 3,500 pounds. And we're only going to be doing the math for one quick jack, so we got two quick jacks, which makes 1,750 pounds per quick jack. So I have some lovely diagrams that are definitely not to scale because I am not very artistic. So we're going to start with our lifting it from the ground. So we have force A, force B, and force C. And we have our 10 degrees here for the hydraulic cylinder. Force C is the amount of force that the hydraulic cylinder needs to create in order to lift my vehicle. And force B is the amount of force needed to lift the vehicle to counteract gravity, the weight caused by gravity. And force A can be ignored for what we're doing. So we're going to start with SOHCAHTOA. Good. So sine of 10 degrees. We're going to do opposite, which is force B, over hypotenuse, which is force C. So sine of 10 degrees is force B over force C. We're going to quickly move our force C and then our sine of 10 because we want to solve for force C. And we know what force B is and sine of 10 is. So we're going to plug those numbers into our handy-dandy calculator. Let's bring them on over. So we have our 1,000. Well, first off, let's find out what sine of 10 degrees is. So we have 10 degrees. What's the sine? It's 0.17364, whatever. We're just going to round on up to 0.174. Now we're going to take our 1,750 and divide it by 0.174. 10,057.47. We're just going to ignore the 0.47. And over here, we're going to do the exact same thing, but for when it's on the safety stops. And the hydraulic cylinder is at 26 degrees. So same thing, sine of 26 degrees, opposite over hypotenuse. We're going to move our force C and our sine of 26 to solve for force C. We're going to plug our numbers in. So 26 degrees, what's it, sine? 0.43837, we're going to ignore the 37. And then 1,750 divided by 0.438 is equal to 3,995.4. We're just going to ignore the 0.4. Now, time to the stuff that you probably don't recognize. The hydraulics and its pressure. So, hydraulics, pressure, let's make that a little darker. Pressure is equal to force divided by area. So, we have a nice little diagram here. I'm going to zoom on in to make this a little more bearable to see. Let's do that again. So, remembering this little equation here. So, we have pressure 1, which is our hydraulic pressure, but we also have pressure 2, a pneumatic pressure, which is 50 psi, which we will have to worry about later. But for right now, we need to know the surface area. So we have the outer diameter of the hydraulic cylinder, which is 1.9 inches. But we also have wall thickness, which is 1/8 inch thickness. But there's 2 walls here. So that comes out to 1/4 inch of the 1.9 being taken away for the thickness of the walls. So that way we have the inner diameter of the circle of the cylinder. So that way we know how much pressure is within that inner diameter. So we're going to find our radius. So 1.9 minus 0.25 divided by 2 gives us 0.825. And then we have the area formula, which is just pi r squared. And we're going to plug in our 3.14, our 0.825, square it, plug it all in, and we get 2.137. We're just going to round up to 2.14, make our math a touch easier. Now, remembering this formula here, we're going to quickly reverse engineer it to be force is equal to pressure times area, which is how we get this, our pressure 1 times area. Now, we have our pressure 2 times area over here because we know what the pressure is, so we could just make this a force. But now we need to solve for pressure 1. So we're going to divide the whole thing over here by area, which gives us force C over area plus 2, because we just got rid of this area here. And then all we have to do now is plug in our numbers. Okay, 10,000 divided by 2.14 is equal to this big old number, plus 50 for the extra pressure, for the extra pneumatic pressure, which gives us 4,749.5. We're just going to round up to 4,750 and make it a nice even number. And I'm not going to do the same thing with this other 4C here, because we like our big numbers here. That is all for the math. We're going to zoom out here so you can see it once again. It's a lot. Hopefully you understand it a little better. Now that we understand the math, let's take a look at the quick jacks lifting my car.
Now keep running because I'm going to put the safety stops in and show that that's the height. Okay. So we're going to drop it down on the stops. Okay. Now, how it raises it off the safety stops. Release the safety stops. Now we're going to bleed off the hydraulic pressure to load.